Okay guys, we had some struggling on our quiz 11.1, 11.2, especially that problem number 7. So I'm going to teach you some basics when dealing with these trig functions that I hope are going to help. And then I actually am going to go over problem number 7 for you so that you can see how it should have been done. All right, here are just some basics, you guys. Let's go back to basics. Remember, in dealing with variables, if I want to do a plus 3a, you know how to add basic variables. It just makes 4a. Treat these trig functions the same. Rules apply. Treat them the same as when you deal with normal variables. So what happens if I have a cosine x and I want to add a 3 cosine x? Can I add those together? Yes, they are like terms because they are cosine x. This is a 1 cosine x. I want to add a 3 cosine x. So what does that make? It makes 4 cosine x. We can add these trig functions. We can subtract them, okay? We can multiply them. We can divide them. There's so many things we can do with them. All right, make sure you have this. Well, if I have 5 tangent x and I subtract 2 tangent x, how much is that going to make? You're right, 3 tangent x, okay? Addition, subtraction rules, they apply the same as normal variables, okay? Just remember tangent x is all one thing. He's hooked together, all right? It's not tangent, it's not x, it's tangent x. He's one complete thing. So treat these as the same as you would a variable. They're hooked together. All right, so knowing that, what do you think would happen if I tried to take a, first back up a minute. Let's talk about what that means right there. Okay, if you see that, the way we read is cosine squared x. You need to understand that this means the exact same as a cosine x that is being squared. Or in other words, it is a cosine x times another cosine x. The reason they put the squared here is because they want to make sure you understand we're squaring the cosine. We're not squaring the x value. So this is the typical way you will see it written, but this is what it means. So don't get confused about that. All right, so back to basics. What if I said cosine squared x plus a 2 cosine x? How much would that make? Well, look at it. They're not like terms. This is a cosine squared, and this is just a cosine x. It'd be like me asking you, say, hey guys, how much is a squared plus 2a? You go, I can't add those together. They're not like terms. That's exactly right. Same works for cosine. So these two cannot actually be added together, all right? And that rule is going to help us when we go to factor, when we go to solve. So when we're solving, again, go back to basics, you guys. When we used to solve and I said, go solve this equation, 2a squared equals a plus 1. Step 1, we always get our variables on one side. We're going to use that same rule when we deal with the trig functions. You know you need to move this a and the 1 to the left side. We get everything to one side so we can get it equal to 0 so we can factor. Why do we need a factor? Because you have a's of different degree. All right, there is no way to join all those a's together, so we set equal to 0 and we factor. So that's what we would do, is we would subtract the a, subtract the 1, and I get 2a squared minus a minus 1 equals 0. And once you have in this spot, you would go through the box method or factor by grouping, whatever you want to do, and you end up with 2a plus 1 and a minus 1 equals 0. What do you do once you get the factors? Once you get the factors, what do? We set each factor equal to 0. So remember those two key things. We're going to use it when we do these trig functions. Step 1, get everything to one side so we can get it equal to 0. Step 1, get it equal to 0. Step 2, factor it, okay? It's not necessarily going to be a trinomial like this. For yours, you're going to factor, when I say factor, it's going to be more factoring out the GCF. Okay, once you have gotten it equal to 0, you have factored the equation, then what do? We take each individual factor and we set them equal to 0 in order to solve, okay? Those are the 3 steps we're going to use, just like you do it in the basics, you guys. We do it with trig functions. So let's see how it works. Here we go. I believe this is number 7 off of the quiz. Once I do this one, I have 2 more sample ones I'm going to do with you if you need extra practice. So take a look at this. I told you step 1, we need it equal to 0. Well, handy, it's already equal to 0. Step 1 is done. Step 2, we're going to factor. First rule of factoring, GCF. So what is the greatest common factor here? What do these have in common? Remember that 2 is just 2 times sine x times cosine x, okay? Treat these like variables. That 2 is just how many I have of them. It's just out in front. So 2 times sine x, there's a times there, times cosine x. What does this have in common with this one? They both have a sine x. That's my GCF. So I factor out a sine x, leaving me with 2 cosine x. You have to have something here. What's left if I factor out the sine x? I have a 1 left. Don't forget that. All right, so I've got to equal to 0, step 1. I have factored out the greatest common factor. Now my next step, set each factor. Here's one factor, and here's the other. Set them equal to 0. So sine x equals 0, and 2 cosine x plus 1 equals 0. All right, how do I solve this? I take the sine inverse of both sides, and that will cancel me with x equals sine inverse of 0. Okay, what does that mean? It means where on my unit circle is the sine equal to 0. Remember my unit circle, that means the y value. So what this means right here, it's saying go find me a y value of 0. Now, if you don't have a unit circle, either make yourself one or go print one off the computer. Go Google unit circle. There's a zillion of them out there. Go find you one, and it's going to make your life so much easier. Okay, so where is the y value 0? So look on here, xy coordinates, boom. That y value is 0. That is at 0 degrees. Where else? Right here, y value 0. That happens at pi. So that means I found my variable x to be 0 and pi. This x does not mean an x coordinate. This is the variable in my equation. Okay, so make sure that's clear because we use x's as x coordinates on the unit circle and we use them as variables in our equation. So keep those clear. All right, now I did this half, but I still have to finish this. Okay, we just minus 1 to both sides. 2 cosine x equals -1. I'm trying to solve for x. What do I get rid of next? That's just a 2 times cosine x, so divide by 2. Now, right here, I want to leave this as a fraction because I know in my unit circle everything's in fractions. So I'm going to leave it as -1/2. So cosine x equals -1/2. I'm trying to get x by itself. To get rid of cosine, I take cosine inverse. That's how we do it. Add 1, subtract 1. They're inverses. Times 3, divide by 3. They're inverses. Cosine, cosine inverse are inverses. That's what cancels it out. So from there, I have x equals cosine inverse of -1/2. Okay, what does this mean? It means on my unit circle, cosine always is the x coordinate. So this is really saying right here, it's saying go find me an x value, an x coordinate value of -1/2. All right, go to your unit circle. -1/2 in the x, -1/2 in the x. There we go, right here. 2 pi thirds. Where else does it happen? Right here, 4 pi thirds. So right here, I get x equals 2 pi thirds and 4 pi thirds. So I got this for x and I got this for x. I combine them all together. My final answer, x can be 0, pi, 2 pi thirds, or 4 pi thirds. Remember, in the directions, it told me I'm solving for any x between 0 and 2 pi. Do not get this confused with when we do a problem that just says find the tangent inverse of -1, okay? Or go find the sine inverse of square root 2 over 2. On those are the ones that we restrict the domain in certain ways, all right? When we solve the equations, it's typical for your directions to change your domain, so you're now dealing with from 0 to 2 pi, which is your typical unit circle, okay? We can use the value straight off the unit circle. All right, that's how you did problem number 7. Tune in if you want to see 2 more examples. If you still want a little practice, I would suggest go grab a piece of paper, press pause, and see if you can do this problem without me showing you, and then hit play and see if you got it right. All right, here's how we do the next one. Sine x cosine x minus 3 cosine x. Step 1, get a equals 0. Check. Step 2, factor, GCF. What is my greatest common factor? Cosine x. Okay, let's factor that out. Leaving me with sine x minus 3 equals 0. Next step, set each factor equal to 0. Cosine x equals 0. Sine x minus 3 equals 0. And now we solve each of those equations. Okay, I'm going to take the cosine inverse of both sides. Those will cancel, leave me with x equals cosine inverse of 0. Notice I always throw that inverse in front of this number because you have to take a trig function, you have to do it to something. You have to take the cosine of something. You have to take the tangent of something. So here we're taking cosine inverse of each side, and that's why it goes out in front. Okay, so what does this mean? Cosine inverse of 0 means on your unit circle, go find me where cosine is x, the x value. Where is the x value? 0. I need an x of 0. Happens up here at pi halves, and it happens down here at 3 pi halves. So far I have x equals pi halves and 3 pi halves. Okay, now let's do my other equation right here. And I can add 3 to both sides. I end up with sine x equals 3. Okay. Oh, one more step. Sine inverse of both sides. I got to solve for x. And x is equal to the sine inverse of 3. Okay. Sine means y. Let's see, that went a little blurry. There we go. Means the y coordinate. Go find the y coordinate that is equal to 3. Go to your unit circle. Are any of these y's equal to 3? No, that's too big. If you ever get a value that's too big for your unit circle, it doesn't necessarily mean it can't happen. It means you need to go draw yourself a triangle. So let's go draw a triangle, a right triangle, when we're dealing with these trig functions. A right triangle, let's label a theta. And what this means is it says, I want to know where the sine, when I take the sine of theta, where do I get the answer to be 3? Well, sine is ops over hypotenuse, so let's label those. The opposite is 3, the hypotenuse is 1. Do you see anything wrong with this situation? Which side is supposed to be the longest side in a triangle? Is it possible for my hypotenuse to be 1 and this side to be 3? No. The hypotenuse has to be the largest side of the triangle. It has to. So what do? We say, this is not possible. I cannot solve a sine inverse of 3. It's not possible. So my final answer are just these two. All right, let's try one more if you're up for it. Here we go. 4 cosine squared x sine x equals 3 sine x. Step 1, get equal to 0. So what are we going to do? We're going to subtract this to both sides. All right, those cancel. Now, are these like terms? Can I take a cosine squared x sine x and subtract a 3 sine x? No, they are not like terms. So I just have 4 cosine squared x sine x minus 3 sine x equals 0. Step 2, GCF. We're going to factor. What do they have in common? They both have a sine x, so we're going to take that out. Sine x, and I have 4 cosine squared x minus 3 equals 0. Okay, set each factor equal to 0. Sine x equals 0. 4 cosine squared x minus 3 equals 0. Okay, take sine inverse of both sides, and I end up with x equals the sine inverse of 0. Okay, sine is the y coordinate. Go to your unit circle. Where's the y coordinate? 0. Right here at 0 and pi. So right here I get x equals 0 and pi. Okay, that's part 1 is done. Now let's go finish the other equation. What do I do first? Add 3 to both sides. So 4 cosine squared x equals 3. What do I get rid of next? The 4. Divide by 4. Remember, leave it in fraction form. Don't change that to decimal. Leave it as 3/4. Okay, I can't take the cosine inverse yet. What do I still have to do? I got to get rid of the squared. How do you get rid of a squared? We take the square root of both sides. So now I have cosine x, I got rid of the squared, right? Equals square root of 3/4. How do you deal with a square root of 3/4? Well, we take it and we take the square root of the top and square root of the bottom. Square root of 3 does not simplify. It's going to stay square root 3, but square root 4 is 2. So I have cosine x equals square root 3 over 2, except, what do you got to do anytime you take the square root of anything? Do not forget your plus or minus. Okay, so I'm going to come up here. I now have cosine x equals a plus or minus square root 3 over 2. All right, last step. Take cosine inverse of both sides. And I now have x equals the cosine inverse of plus or minus square root 3 over 2. What does that mean? Go to your unit circle. Find me anywhere on the unit circle where the x value can be a positive square root 3 over 2 or it can be a negative square root 3 over 2. It can be either one. All right, so here we go. Square root 3 over 2 has to be the x value and can be positive or negative. Boom, it happens right here at pi 6. Happens here at 5 pi 6. Happens here at 7 pi 6 and 11 pi 6. Notice, square root 3 over 2 can be positive or negative in any of those. So back to my answer. X can be, what were those? Pi 6, 5 pi 6, 7 pi 6, and 11 pi 6. But don't forget, whoops, I bumped my paper. We got this answer over here and this one. So I throw it all together. Final answer, x can be 0, pi, pi 6, 5 pi 6, 7 pi 6, and 11 pi 6. This one actually has 6 answers to it. All right. That went a little blurry. Sometimes it goes blurry. I don't know why, you guys. All right. Can you see that final thing? There we go. All right. Hope that helps you guys and be able to figure out how to solve these equations with trig functions. Study hard, and I hope you do better on this Form B of your quiz. Don't forget you can sign up for a Zoom meeting with me, and I'm happy to help you and explain any of the other problems if you don't know how to do those. Good luck, you guys. Bye.